Without further ado, I am pleased to welcome Thomas Quinn for our guest speaker tonight. Welcome, Tom.
Okay, can you see my screen?
It looks good.
Okay, good evening, everybody. It's a little strange to be talking to you from what used to be my son's bedroom up in Seattle, but I'm assuming I'm reaching out to people. Thank you for the invitation, Clarissa, and the opportunity to talk with you about salmon and trout. I'm a professor at the University of Washington, Seattle campus in the School of Aquatic and Fishery Sciences. And I got my PhD 40 years ago last month, and I've been teaching at the UW since 1986. My students and I study various aspects of the ecology, behavior, and conservation of salmon and trout. I've had many projects up in Alaska, in British Columbia, here in Washington, and other parts of the world, including some small collaboration in Ireland, a large project down in New Zealand, and other things. So that's who I am. I'm kind of a salmon and trout guy. And I realize there's a little bit of a killer whale orca focus of this series, but we'll circle around to them eventually. But we want to talk about salmon. So here's my introduction. This is a large chum salmon struggling up a small stream. What I'm hoping to do here are four things. The first is to review some information, and some of you may know some of this, but I doubt all of you will know all of it, on when juvenile salmon migrate down our rivers and come into Puget Sound. So if we're thinking about Puget Sound as habitat for fish, the question is, well, when do they get there? Then we'll consider how much of their lives are spent within Puget Sound as opposed to going out somewhere to the open ocean. And then at what time they come back through Puget Sound and go back up their rivers to spawn. And so we'll be bracketing that period when they use Puget Sound. We'll be talking then about some long-term changes in migratory behavior. We have seen some changes that are very interesting. We scientists do not fully understand them. In fact, we hardly understand them at all, but they are very important for humans and for the ecosystem, the various consumers that prey upon, feed upon salmon. Then I'm going to end up primarily focusing on Chinook salmon and consider some interesting data generated by our State Department of Fish and Wildlife, collaborator of mine, on some trends in the abundance of Chinook salmon, their size, and also patterns of Chinook and Coho survival in Puget Sound. And then, unlike most lectures where the speaker ends with a conclusion, I'm going to end with some questions, things that we don't know, but are very, very pressing. And then I'd like to leave plenty of time to take questions from you folks. So I hope I can interest, enthuse, inform, and invigorate you, and then you go on and have your dinner. So every year, millions, many millions of little salmon and trout swim down our rivers and enter the small and large waters of Puget Sound. And so these are larger rivers like the Nisqually, the Skagit, the Stilaguamish, small little trickles here and there. And each little fish, of course, is there for the first time he or she has ever been to Puget Sound. Mom and dad are not around to lead them as are other migratory birds. They have to decide where to go. It's a big place. And some stay around within the waters of Puget Sound for a while, some stay around for their whole lives, and some run for the door as quickly as they can. And there are costs and benefits. There are predators, herons and seals. There's also prey to eat of a variety of sorts. And these fish have to make their way in Puget Sound as opposed to going out to the Pacific Ocean coast, as some do, or out to the open North Pacific Ocean, as others do. So the first sets of data, these were shared with me by the Stilaguamish tribal biologist, and the photo on the lower left is the Stilaguamish Estuary, and some from the Skagit River. This is the Skagit River with a lot less water than it's got now. And these are traps that are deployed by fisheries agencies to catch little salmon going to sea. We're just going to think about when they go to sea. And I'm going to show you data for 8 species. And there may be some of you that were not aware that we had 8 different salmon and trout species swimming into Puget Sound, but we do. We have 8 native species here in the Puget Sound area. And the key is that some of them go a little earlier and some a little bit later, but in basically April and May, all the species are going down to Puget Sound. So whatever they do different, it's not because they arrive in Puget Sound at different times. They've all got their own sets of instructions. So what I'm showing here, these are bar graphs. If you can see my mouse, the red are the April and May counts. And so these are the proportions of all the juveniles going to sea in those different months. And so you can see Chinook salmon, some go as early as February and March, but a lot of them in April and May. Chum salmon primarily in April and May, maybe not quite as early as the Chinook salmon. These are photographs of each species. Pinks also primarily in April and May. Sockeye a little bit later, but mostly in May. I mean, May is the time to go to sea if you're a little fish. Coho salmon, again, primarily in May. I mean, there are exceptions and we realize that, but there's a lot of little fish going downstream in April and May in these rivers. Steelhead trout, and I should point out that most of these photographs are taken by me, but the steelhead, bull trout, and cutthroat, and a few of the others are beautiful pictures taken by John McMillan. John works for Trout Unlimited over in Port Angeles and is a superb fish conservationist and photographer. But again, you can see that all of these species, some of them are a little bit later, the bull trout into June and July, but the spring is the time when all these little fish are going to sea. So we're thinking, how is Puget Sound used by little fish? You have a huge, huge influx of just tremendous numbers entering at about the same time. The second thing is, how long do they stick around? And so what I did was collaborate with James Losey, and the Washington Department of Fish and Wildlife maintains a data set of fish that are caught by sport fishermen, and the regulations vary, but for many, 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 many years, decades, Puget Sound has been open to sport fishing at all months of the year, and people are required to record their catch. And the State Department of Fish and Wildlife estimates how much effort, like how many people are out there fishing and how many fish are caught. And so we use this data to figure out how long those different species stick around in Puget Sound. And if you have some anglers in the audience, they may say, oh yeah, that's about right. Some people who are not sport fishermen might not be aware of it. Some of the species, particularly cutthroat trout and bull trout, are not legal to be kept when sport caught in Puget Sound. And so we relied on research data from the Skagit River and also in South Puget Sound to capture those fish because they're not suitable data. And steelhead are virtually never caught in the recreational fisheries. And so the data were too limited to be informative. So what I've shown here is in red is the month that had the highest catch rates, and that's shown as 100%, and everything else is relative to that. So you get very, very, very few sockeye salmon caught during the winter in Puget Sound. A large whoosh of them comes through primarily to Baker Lake in the Skagit and to Lake Washington, and then they're basically done. They come through in a whoosh. Pink salmon come around later. Again, very, very few caught in the winter. A few, but very few. And large numbers are caught July, August, and September, and then they're done. And chum salmon are later still, primarily in November. And we know this from the sightings of fish. McLean Creek down near Olympia, of course, has got a park. Kennedy Creek near Shelton. So these all have their own specific timing. So these species are all feeding out in the middle of the ocean and come barreling through at their own specific times in the summer and the fall. In contrast, when we look at Chinook and Coho salmon, we get a completely different pattern. The highest catch rate is actually in December for Chinook salmon. Substantial numbers of them are caught year-round. In fact, the highest catch rates are in the winter. And of course, the sports fishermen will say, yeah, we call those blackmouth. So it's been known to ichthyologists and tribal fishers for, well, as long as we can record back that salmon, particularly Coho and Puget and Coho, are in Puget Sound throughout the year. And Coho is a slightly different pattern, but again, we have some of them caught throughout the year in Puget Sound. So completely different pattern. Now we know that some of the Coho and Chinook salmon migrate out to the open ocean coast along the coast of Washington, Oregon, Vancouver Island. But a goodly fraction seems to spend all or most of their lives in saltwater within Puget Sound. So completely different from those other species. Cutthroat trout are interesting. They show different patterns in the north and south part of Puget Sound. So in northern rivers like the Skagit, cutthroat trout spawn in the spring and then migrate down and enter Skagit Bay May and June, and by late summer, they're already back upriver. So they're really only in salt water for a few months. Bull trout, similarly, the bull trout actually spawn in the fall, spend the winter in the rivers, migrate down in the spring, and are caught by beach seines and other gear, and then they scoot back up, we think because they don't like the warm water in the lower river. So they leave Skagit Bay and the lower Skagit River and the Stilaguamish and those warm rivers to dash up to the cold waters at the headwaters and hang out all summer and then spawn. So again, for each of these species, very different periods of time when they're available as prey and predators and searching for anglers. Interestingly, in South Puget Sound, down near where you folks are, the cutthroat display completely different patterns. There they again spawn in the spring, but they're essentially a saltwater fish that only briefly goes back into fresh water to spawn. And here we have records. They're actually caught in beach seines quite regularly, right off the mouths of rivers. They'll run up, spawn quickly, and just drop back down into salt water, and typically occupying nearshore habitat, unlike the Coho and Chinook salmon that will spend more time offshore. So each of these species and even different populations has their own timing and how much of the time they spend in Puget Sound. We know from tracking bull trout and cutthroat trout that they rarely go more than 5 or 10 miles from their home stream, even though they could, but they don't. Whereas the sockeye run for the door, the steelhead dash out to the middle of the North Pacific Ocean, while the cutthroat that might have been sharing the stream with them scarcely goes outside the estuary. And it's not the lack of swimming capacity, they just express different patterns. And the last part, of course, is when do they go back upriver? Because, of course, their availability to commercial, to sport, to tribal fishermen, as prey to marine mammals, killer whales, and so forth, depends on when they're coming back through. And again, we're relying on catch data managed by the Washington Department of Fish and Wildlife. In this case, specifically the Skagit and the Stilaguamish rivers, although these are not unrepresentative of other rivers. So Chinook salmon, we have some early runs, but the bulk of them are coming in June, July, and August. Sockeye salmon also fairly early. The bulk of them come in June and July, and then those runs are over. So you can visualize sockeye leaving freshwater, going out to the North Pacific Ocean and come barreling back in. Pink salmon come in a little bit later with a peak in September, mostly August, September, and October. Coho salmon a peak in October and somewhat later. Again, each species has its own characteristic pattern of timing. Chum salmon later still, so November and December. So many of the streams now have chum salmon. And I've adjusted the calendar to push it because the steelhead, some are caught in rivers year round, but the bulk of what we would call winter steelhead is coming in from about December to March. So each species has its own unique timing. Now, if we put this information together, for species like Coho and Chinook salmon, we have essentially a group of them that feeds year-round in Puget Sound. That is, some individuals stick around while others go out to the coast. And this is a really interesting phenomenon. And it is very important from a number of perspectives. The Chinook and Coho salmon that are feeding in Puget Sound are available to anglers. They're available to predators like killer whales, harbor seals, and so forth. They are also, however, susceptible to the uptake of chemical contaminants associated with such as PCBs from our industrialized rivers. And that has consequences because those PCBs get passed on to the harbor seals and the killer whales that will feed on them. And in fact, one of the main concerns for the health of the southern resident killer whale population is the uptake of contaminants, and those are chiefly coming from consumption of salmon. And those salmon accumulate those contaminants because they feed within Puget Sound, because members of the same species feeding off the coast have much, much lower levels of contaminants. So from the point of view of ecology, conservation, health, and the fishes themselves, the fact that they stay or go is a very consequential thing. What's curious, we don't understand this fully, is that the fraction of Chinook salmon and Coho salmon that stay in Puget Sound seems to be changing. So how do we know this? Well, what we have over the decades, roughly 50 years, is records of the catch during times of the year when the salmon would be feeding in Puget Sound rather than coming back to spawn. So in the middle of December, for example, Chinook salmon aren't spawning. So if we catch one in Puget Sound in December, that fish is not just about to run up its stream to spawn. So those are what we would call feeding fish, immature fish. Now in the middle of the summer, those resident fish will still be there, but then there will be an influx of fish coming from the coast. So what we did for each of these different species was we divided the year into periods when the salmon could be considered resident if they were caught in Puget Sound, and then a period of the year when we could consider them migratory, even though during that migratory period, we would still have some resident fish around. When you do that for sockeye and chum and pink, you get very, very few caught in that resident period. It's maybe 1%, 2%, indicating that while we do have a few of those fish that stick around, and I do know that they exist, the vast majority of pink, chum, and sockeye and steelhead migrate out to the ocean. On the other hand, when we look at Coho salmon, each dot represents an estimate for a year. And this is a catch per trip, that is catch per angler. It's multiplied times 1,000. The anglers aren't catching 144 fish a trip, right? It's 1/1400th of a fish per trip, but it's not zero. And you can see that during the period when they're migrating, the return timing, it's bouncing around, but actually there are at least as many as there were in earlier periods. What's interesting is the resident period went down very dramatically, although in the last couple of years, it seems to have swung up, but a dramatic decline in the catch rate by anglers. And it's not as though people can't catch fish. In fact, if anything, anglers have gotten better, right? Because we have trolling motors and we have GPS and we've got fish, all kinds of electronic things. So the gear all favors the fisherman now. And in many cases, of course, it's the same people, but you have quite a dramatic change. But you can notice that on the overall yearly basis, we get almost as high a catch rate in the winter on the resident coho as we get in the summer. Now, maybe more people may not go fishing in the winter, but when they do, they're almost as likely to catch a coho in the winter as the summer. Another thing is curious as well, some of them are out in the open Puget Sound, they're also right along shore. In fact, you can cast a fly or a spinner from a beach and catch coho year round in Puget Sound. You might not, but they are there. So there are a number of them that are feeding in the nearshore area year round, while members of their same population may be off the coast of Vancouver Island or down off the coast of Washington. In the case of Chinook, we also, this may surprise some of you, but the actual catch rate during the migrant period in the summer has bounced around, but is not dramatically down. But the resident component of the Chinook population seems to be declining. And in both cases, the resident component peaked around the 70s. And we do not know what controls it. So you think about these little fish, they're entering Puget Sound, they've never been there before. Nobody that they know has ever been there before. Their mom and dad were long dead before they were born, unlike migratory birds or the humpback whales that migrate from Hawaii up to Alaska. They're following their parents. These fish have no one to guide them, no one to lead them. What do they experience that would cause them to stay in Puget Sound or to go out to the coast? And we frankly don't know. But again, it's a very consequential matter, and the proportion seems to be changing. And what we've noticed, I'm sparing you all the details, but the fraction that stays in Puget Sound is higher in years when the water is cold. And in general, for salmon, cold is good. Now, we don't know what it is that cues them. I mean, how do they know that it's colder this year than it was last year? They have no way of knowing that, but there is something in the environment, and it could be the temperature itself, or it could be that under years when the water is cold, there's more to eat or fewer predators. We don't know what the signal is, because remember, the little fish can only see, maybe a yard or two in the water. They don't know that Anderson Island is there and McNeil Island and Vashon. They don't have a map, right? They have to simply react to what they encounter, and some of them stick around and some of them go. And those proportions seem to change, and they vary with environmental conditions. They vary a little bit with the size of the fish and the date when they entered, but not a lot. And as far as we know, they don't seem to differ much between wild and hatchery fish. There are some fishermen that will tell you that the resident fish are all produced in hatcheries. Well, that's only true because almost all the salmon in general are produced in hatcheries. Long before we had hatcheries, we had resident salmon. This is a completely natural phenomenon. It's really important to bear that in mind. We may or may not be able to tweak it a little bit with the way in which we grow fish in hatcheries, but we have not created this phenomenon. This is a natural part of the biology of the fish. So what do we know about these residents? I call them residents in quotes, but that's the jargon that we often use. So this is a photo taken from the Seattle Aquarium. This, of course, is one of these subadult Chinook salmon, such as might at this time, like literally right now, be swimming around in Puget Sound. And we know that there are many thousands of fish, more or less like that, swimming around, some of which will spawn next year or some subsequent year. People studied them a long time ago, and these are data, I can not embarrass myself, these data were reported before I was born. And fishermen and fisheries biologists have long known that these resident Chinook salmon are somewhat smaller than those that migrate out to the coast, for reasons that are not entirely known. You think, well, if the growing conditions are poor in Puget Sound, why would any of them stay? Why don't they go? And perhaps there is some greater survival that they experience here in Puget Sound, which might compensate for the slower growth. But these data were reported in inches, and you can see quite a substantial difference. Overlap, sure, there's some big fish here in Puget Sound, but quite different. Interestingly, we see the same thing when we look at Coho salmon. Again, these are old data. So there's a Coho salmon, one of these subadult fish, again, photo taken from the aquarium. And again, fork length, this is the length of the fish. You can see the fish caught in Puget Sound were substantially smaller than those along the coast off the edge of Juan de Fuca Strait, substantially smaller. And in fact, sport fishermen will tell you late in the summer, all of a sudden, like people of the world got the big ones are in, as though the big ones that have been feeding off the ocean coast come in, and people will see a marked increase in the number of large fish. It's not because the fish in Puget Sound all of a sudden started to grow really fast. It's because the big boys and girls that were feeding along the ocean coast have come in. And again, people who sport fish a lot would consider this common knowledge, and it's been around for quite a long time. And so again, for the Coho salmon, like the Chinook, despite growing quite a bit slower, and of course you think, well, so what? But smaller females will make fewer eggs and smaller eggs. Those smaller eggs will make smaller juveniles. Those smaller males will not be as competitively attractive to females as larger males. So there's a lot of reasons why a salmon would want to be big. So by staying in Puget Sound and not being as big, they're clearly paying some cost. And we would assume that they are getting some benefit from that, perhaps in survival, although we don't know that. I mentioned earlier that pink and chum and sockeye basically clear out of Puget Sound, but there is a fraction of all of those species that sticks around. What's really curious is decades ago, there seemed to be a lot more of those resident pink and chum salmon. So many that back in the 1950s, the State Department of Fisheries then was able to purse seine them up and get a sample and look at how much smaller they were. This is in centimeters if you don't think metric. This is if you were to weigh the fish, this would be a huge difference in the weight of the fish compared to ones caught at the same time, late June, early July, out off Juan de Fuca coast. In fact, there were enough resident pinks in Puget Sound around Tacoma that they rounded them up with purse seines, tagged them to see which rivers they went to. And you talk to fishermen now, this is it's unheard of to catch large numbers of pink salmon within Puget Sound. But back then there were, again, when the water was colder and they grew slower. So the slow growth of the resident fish is a very common phenomenon across these different species, even though they eat different things. So there's something really common about that. So resident fish tend to grow slower. In addition, we find that when we put sonic transmitters in them, and this is something that my group does, and you follow them around, they don't go all over Puget Sound. They tend to stay in their home waters. So coho salmon that are produced in a hatchery or in a river in Hood Canal that reside may spend their whole lives in saltwater within Hood Canal, even though they can swim around to central Puget Sound in a matter of a few days. Those that are entering central Puget Sound, area 10 if you're a sport fisherman, even though in a day or two they could swim all the way down to Tacoma and Olympia and back, they don't. They might be around West Seattle and they pop over to Bainbridge Island, and then they go over to Alki, and then they go up to Elliott Bay, and then they go around to Vashon. Back and forth, they're active. They're not sedentary, they're swimming around, but they don't explore all the waters that are available to them. Even though at the same time, members of their same population are out off the coast of Vancouver Island, or in the case of some of the Chinook, practically up to Alaska. So if they decide to stick around, they tend to really stick around. So again, why do we care? We care for a variety of reasons, and the we is kind of the collective of organisms, humans and non-human, around here. And we know that, or many of you probably are aware, that the southern resident killer whales are essentially exclusively feeding on fish. And while they do eat other kinds of fish, most of the fish that they eat are salmon. And in fact, most of the salmon that they eat are Chinook salmon, although they also can feed quite heavily on those late runs of chum salmon. Periodically, there will be reports of killer whales down in some of the southern Puget Sound inlets like Totten Inlet down near Katy Creek or Henderson, and they're in there rounding up the chum salmon. So the abundance and the availability of salmon is extremely important. If the salmon are only available to killer whales as they're dashing through Puget Sound up to their home streams, that's a very, very different opportunity for those whales to feed on them than if they're around for a long period of time. So the distribution of fish is extremely important. Now, of course, if the salmon all migrate up north, and the northern resident killer whales can eat them. So the salmon are going to go someplace, but they might be going someplace where the killer whales already have plenty to eat and leaving someplace where they have less. In addition, of course, we have osprey. They're a significant predator on juvenile salmon. I've watched them dive bombing smolts and many, many other kinds of birds. I'm not trying to demonize or lionize any of these individual organisms, but the appearance of those many, 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 many millions of juvenile salmon does not escape the notice of great blue herons, ospreys, eagles, loons, mergansers, and a wide variety of birds. Also river otters, which are very common in Puget Sound. Harbor seals, of course, are a major year-round resident, and they're staying warm in cold water. So they're going to be feeding on fish. It turns out that salmon are not really the primary prey of harbor seals, but they definitely eat them. They're primarily eating other fishes, but they'll definitely eat salmon when they get a chance. So the well-being of these different organisms in this ecosystem, and we also would include all the lesser things that you wouldn't think about so much that would be below the surface of the water that you might not notice that would also feed on salmon. But in addition, of course, people, and I sort of have just three images here to give you the perspective. Obviously, for many, many, many centuries, millennia, native peoples fished for salmon using a wide variety of types of gear. Their ingenuity in catching them is well known, and we're highly attuned to the patterns of timing of arrival of these different runs of salmon. Obviously, the availability of that much food in a relatively convenient manner did not go unnoticed. We also have recreational fishermen, such as this fellow here, who's part of the Tengu Salmon Derby here in Puget Sound. and non-tribal commercial fisheries. So we have a variety of fisheries interests. And of course, people eat salmon, and obviously there are vegans and vegetarians who don't, but large numbers of people do. And so the extent to which those salmon are healthy as food or have contaminants is something that people would want to know about, because they would be transferred to human consumers just as they would be transferred to harbor seals, killer whales, and any other animal. And those uptakes of contaminants are related to where and on what they feed. And the things that they eat in Puget Sound, such as herring, have higher levels of contaminants than do the things that they would eat out along the coast. Because many of our herring are in fact non-migratory too. They stay within Puget Sound and accumulate higher levels of contaminants than do herring off the coast. So the ecosystem is connected by the migration or lack of migration by these different things. So what else do we know? What are the trends? And here I'm relying primarily on data from my friend and collaborator, James Losey, who works for the State Department of Fish and Wildlife. One question is, are there more salmon than in the recent past? And most people would say, well, of course, there are far fewer. That's common knowledge. Maybe. Are they the same size? Or is the size changing? And of course, that's consequential, because if you're a killer whale needing to eat, or a person needing to feed your family, it's not just the number of fish, but the size of the fish, the mass, the weight of the fish that matters. And in addition, if the fish are getting smaller, that means those females will produce fewer eggs. And so you will have fewer offspring from a small female than you would from a large female. And so all of those things are actually extremely consequential. And another question is, well, we used to get them for free from our rivers. Now, do we get them for free or do we pay for them? And again, I'm giving full credit to James. The second author is Ellie Kinley, one of my former students, published this very interesting paper, multi-decadal look at all the species of salmon in Puget Sound. And they were generous enough to share some of the information with me. So the first question is, are there more or less abundant or about the same? And I would ask you to take 3 seconds and formulate an answer. Chinook salmon in Puget Sound, about as many as there used to be over the last 50 years, more or fewer? I think many people, maybe even most, but certainly many people would say that there are fewer. And so what does the evidence suggest? Each dot represents an estimate. These are estimates, of course. You don't get an absolute head count, but collected in an unbiased manner with respect to the eventual outcome. And you see that there are about as many as there used to be, or maybe even a whisker more. And many people would find that surprising. There are not a dearth of Puget Sound Chinook salmon. This is not so. Huh. Okay. However, the proportion of wild origin fish has gone down markedly. So in early, well, of course, earlier, they would have been 100% wild. As of the 60s, we were starting to gear up hatchery production, and we saw a rapid diminution in the proportion of naturally produced fish. So we have essentially, in maintaining the head count, we have done that by largely replacing declining wild populations with replaced hatchery fish. So if you went to the rivers, you would see fewer fish on the spawning grounds, markedly fewer. We have in some sense masked that from one perspective, or compensated for that by the production of fish in hatcheries, of which of course require money. You know, we used to have them for free. And that's not to say that we shouldn't, but it's worth bearing in mind that the reliance on hatcheries in Chinook and in Coho salmon is very, very prominent here. Very, very prominent. I'm not showing the data for Coho salmon, but it would parallel it. They're also somewhat smaller. Now, these are weights in kilograms, forgive the scientist and his metrics. But an 8 kilo fish, you know, that's like about 20 pounds. 18 pounds or so. So they have not gone down a huge amount, but they have definitely gone down. The average weight of coho salmon went way down. It went down alarmingly fast and then bounced back some. So not all trends are downward over all periods of record, but we are actually seeing all up and down the coast declines in the average body size of Chinook salmon. It's quite pronounced. Not every single river in every single year, but many, many populations, including ones in Alaska, in British Columbia, Washington, and farther south, are seeing smaller fish. And again, smaller females will produce fewer eggs. Smaller eggs will not be able to bury their eggs as deep in the river gravels, which means they will be more susceptible to the scouring flood, such as we've just seen in Olympia River. So there are a number of reasons why the change in body size, the decline in body size, is consequential. Survival, these are data reported by Mara Zimmerman, who formerly worked for the Washington Department of Fish and Wildlife, for the Strait of Georgia and Puget Sound. And what you have in blue, these are annual estimates of the survival rates of wild, and the black is hatchery coho salmon. And they used to have survival rates on the order of 20 or 30%, and now we're down to about a tenth that. So a really big change. In the late 70s, 20 to 30% marine survival was common, although always lower from hatchery fish than wild fish. And a lot of year-to-year variation, but things have dropped. So you realize that you can produce more fish in hatcheries, but if the survival of those fish varies tenfold, it's very, very difficult to make up all of that difference. And the causes of these are complicated. Some of them are probably related to global warming, changes in the food web, predators. Not a simple answer. So rather than being the typical professor and wrapping it all up with the conclusions, I'm going to wrap it up with some questions. So survival rates in Chinook salmon are actually not down as much as coho, so they're doing a little bit better in terms of survival, but we have an increasing proportion of hatchery produced fish. If you're confused, join the club. Many of us scientists, and I include in that folks with the federal agencies, the tribal biologists, the state biologists, ponder these data, we debate them, trying to puzzle things out. So the question really, not just for the scientists, because we're only a small fraction of the voters, but the citizens and residents of the state, what do you want to do? And if you're interested in self-sustaining salmon runs, which I think many, most, almost all people would, I think there are relatively few people who would not value salmon at all. We want to have self-sustaining wild runs. We don't want to have to pay to produce all of them. We also want to have viable fisheries. This includes ceremonial fisheries for tribes, commercial fisheries for tribes, because of course they're co-managers of these fisheries, recreational and non-tribal commercial fishermen. These are ways to put food on the table for individuals and for commerce. And also enough surplus salmon, populations that are healthy enough that it's okay if the seals eat some, and it's okay if the killer whales eat some, and the carcasses will rot in the streams, and the decomposition will feed the insects that will feed the trout, and the insects will be fed upon by songbirds and a whole host of ecosystem benefits. If all of the salmon go back to hatcheries, we lose those broad ecosystem benefits that the salmon provide us when they come back, spawn, and then die. So I'll leave you there and take questions. I hope I've given you some things to think about, maybe surprising you with a few of them. I live and breathe salmon, so I will take any and all questions. And thank you for your time. This is actually my brother-in-law, who was fortunate enough to catch a good king salmon out in Puget Sound. The wild salmon, the tribal and non-tribal enhancement groups are all dedicated to this. And I thank you for taking a little bit out of your day to listen to this. I'll stop now and take questions.
Thank you, Tom. That was interesting. Not what I expected. Expected to just see like it just plummet down and not stay the same. What is this?
It's a little tricky.
But yeah, if anyone has any questions for Tom, type them into the comment section below and we'll get to answering them. To start off, I do have a question.
Go for it.
When we had the salmon returning, people were asking why they changed colors, and I felt that camouflage would be a nice way to change from the silver to like darker colors, but then that doesn't make sense with the red. But then when I looked it up, it seems that it's mostly just finding a mate. Do you want the bright colors?
Well, the colors that salmon have at the different stages serve different purposes. So when they're living in streams, they have what we call parmarks, these little brownish blotchy things, and those are to make them less visible to predators. And so if you took the little salmon and looked down on it as you would if you were a kingfisher or a heron, those little brown blotches look like little pebbles. Actually, if you look at like a coho salmon from the side, they have very bright colors, but those bright colors are for territorial display. So they're brightly colored when viewed from the side because they're waggling their fins to each other, but they're cryptic when viewed from above. They go out to the ocean, they get that kind of bluish gunmetal gray top. And if you take a salmon and you look down on it, if you took a salmon like you bought in the market, if you look down on it, all you see is bluish gray. When you look up at it, all you would see would be white. And so they're essentially trying to hide in open water. Then when they come back to the streams, males and females start to look different and the different species look different. And a lot of that is for communication during mating because you don't want to mate with the wrong species. And in many cases, those colors signal status. They have the red pigment in their meat is transferred to their skin because at death, those salmon the meat is virtually white. The females transfer some of the red pigment to their eggs and some to their skin, the males to their skin. So they're in some sense showing off how successful they were at feeding at sea. And we know that sexual selection mate choice tends to favor large and also colorful fish. So they're trying to signal that they're the right species so they don't get their eggs fertilized by the wrong species, but also signaling their status. I work up in Alaska where people say, well, gosh, these sockeye are blood red. They must all get eaten by bears. Well, turns out bears are not completely colorblind, but they have very poor color vision. Like many predators, they have very, very good low light vision, but they don't have good color vision. So predators do not see as we do. We see color much better than they. So some of these colors that might strike us as garish and conspicuous are less so to the bears, which in fact can catch them perfectly well at night. So what we see and what other animals see isn't necessarily the same. The fish, of course, see color very well. They have very good color vision. But it's a great question.
Yeah, good to know that. Yeah, well, I just assumed that bears could see these bright red fish, but they can't. So that's cool.
Not so well.
We've got some other questions. Does the decline of salmon weight relate to the fact that they are more hatchery fish than wild?
This is a good question. This is a very good question. And there is something to it. There are various reasons why the average size goes down. So one of the curious things about salmon is the larger the individual is when it goes to sea, in general, the fewer years it spends at sea before it comes home to spawn. It's as though there is some relationship between how big it is, because each year that fish has to decide, I mean, it's not thinking it through, do I return to spawn this year or kick the can down the road and think about it next year? And we know from many, many different studies that the size of salmon when they enter salt water and their initial growth controls how long they stay. And in general, in hatcheries, the young fish are released at a larger size than the wild fish, in part because they're fed highly nutritious food. They're often held in slightly warmer water than would occur because, let's say many of the rivers now are very cold, but hatcheries may use well water, which is somewhat warmer. So in releasing larger smolts, larger juveniles, in many cases, the hatcheries encourage a younger age at return. So that is not all of it, but that is part of it. Yeah, that's a very astute question.
I hope that answered your question. And another one is, how do we differentiate wild salmon stock versus hatchery stock as a way towards the future for humans to support?
Does the person mean how do we distinguish individuals, like when we have them in our hands, or how do we decide what we want to have? I'm not sure which direction the question is going.
Both.
Well, the fish are often marked before they are released from hatchery. So there's a small fin just, okay, I'm going to show you right here. There's a little fin just in front of the tail on the top called adipose fin. It's called adipose because it's a fatty fin. It's not a rayed fin. And in hatcheries, the removal of that fin signals that that fish was hatchery origin. So for example, if a sport fisherman catches a salmon, they may be obligated to let wild fish go while the regulations may permit them to retain to keep a hatchery fish. And so the removal of that adipose fin signals it. There are some other marking techniques, but the main way, the primary way, is to do that for the people that are catching fish in Puget Sound. Of course, when the fish returns to a hatchery, we have that additional source of information as opposed to a river. But for people catching them, that's got to be signaled by some mark like that, or internal tag. What fraction of wild fish we want or need is a more complicated question. You know, ideally, from the point of view of wildlife, we want modest numbers of salmon in all the rivers rather than a small number of rivers with hatcheries getting all the fish and everybody else getting no fish. And the hatcheries, because they protect the fish during their juvenile life stages, can provide a larger number per capita than a wild fish. And so the typical reaction is to start fishing harder. And the harder we fish on the hatchery populations, the more we crush the wild populations. And so many of the coho, for example, have just been overfished because we've set our fishing rates to rates that are appropriate to take full advantage of the hatchery fish. And you think, well, we produce the hatchery so we can go fishing. You can't produce the fish in the hatcheries and tell us we can't go fishing. That's a bait and switch. So the hatcheries in some way are almost a victim of their own success, right? If the hatchery works really well, we will want to go fishing hard, and we will overfish the wild populations, which were not unsustainable, but not able to take that level of fishing. So we have a policy question: how many hatchery and wild fish is a good balance, but the individual fish is identified by a mark.
So the next question here is, why are there so many more species of salmon on the Pacific coast than there are on the Atlantic coast?
That is a really, really good question. The person asking the question, for those that aren't familiar, there are Atlantic salmon native to both the European and the North American side of the North Atlantic rim. There are brown trout, which are native only to the European and Asian side. Although interestingly, there are native brown trout in North Africa, and all the way over to Turkey and Iran and Spain. So brown trout are very, very widely distributed, but not native to North America. And in the east coast of North America, we have brook trout. So we have basically 3 native salmon and trout species. And we have 9, 10, 11, 12 here in the Pacific Rim, so markedly more on both the Asian side. So in Asia, they have all the species that we have. They don't have bull trout, but they have another char species and another species called taimen. So there are plenty of, although they don't have cutthroat, interestingly enough. Cutthroat are only on the North American side. It's as though they haven't found Asia yet. And there's an Asian species referred to as a cherry salmon that has not found North America yet. there are some geologists that say that the nature of the landforms cause that. I can refer your questioner to the papers that report that if he or she is interested. It's kind of an unknowable thing from a scientific standpoint because there's no experiment we can do. There's no kind of control and replicate. It's a very, very noticeable thing though. And now another thing to bear in mind is that these are relatively old species. So salmon or different salmon species diverged on the order of 4, 5, 6 million years ago. So they're quite old as species. And so, of course, there may have been more species earlier that went extinct. In fact, we know that there were some fossil salmon that no longer exist. Unfortunately, the fossil record for salmon is exceedingly poor, partly because the glaciers have gone back and forth and ground up all of their bones, partly because predators and scavengers eat them, and also the river gravels tend to pulverize them. There are some marvelous, truly marvelous sockeye fossils in the Burke Museum that were actually collected in Puget Sound, and they're almost 1 million years old. They're like 900,000 years old. And other than being a bit big, they look just like sockeye. I mean, it's like when you took a sockeye skeleton and just laid it in plaster of Paris, it looks just like these fossils. They're really worth seeing. They're on display in the Burke Museum, but the processes that generated that are very difficult to know. I don't know. I have no good explanation, and I'm not sure I buy the ones that other people have. So that's a mystery that will not be resolved tonight.
Sounds like science.
But it's really true. It's very noticeable that there are many more species here. That is absolutely correct.
Someone's going to have to start their dissertation and start looking at it. And
yeah, that wouldn't be an easy one. That wouldn't be an easy one, but worth a try.
Another, hopefully an easier question is, what drew you to working with salmon? And do you have any advice for aspiring biologists and naturalists?
Well, I didn't grow up around here. I grew up in New York City, city kid, where the salmon were with cream cheese on a bagel and the bears were in the Museum of Natural History or the Bronx Zoo, but I was always into fish. My parents were both professors of English literature, so I grew up valuing reading and scholarship, but I kept tropical fish. I remember very, very clearly in 4th grade, I was a bit of a daydreamer in truth. The teacher had a fish tank. I kind of sat in the back of the classroom watching the fish, and I asked my parents to get me fish tank for Christmas, and they said, well, son, you'll have to clean the filter and do all the maintenance. And I did. And it sounds corny to a new generation, but you cannot underestimate the power of the Jacques Cousteau and Rachel Carson era. Many people like myself were turned on to the possibility of going underwater, scuba diving, and the beauty of the writing by Rachel Carson. Her book, The Sea Around Us, galvanized a whole generation. I learned to scuba dive as early as I could. So it's always been about fish with me. I go fishing, but I'm not particularly skillful. I just go fishing mostly just to get out where the fish live. And I came out here to graduate school specifically to study salmon migrations. I worked in British Columbia for a few years, and then I came back to UW when they offered me a job. Salmon are a marvelous animal. Their migrations, their homing, their life history, their connections to people really grabbed me as soon as I came out here. But I was a tropical fish kid when I was little.
So start early.
Well, it doesn't hurt. And if young people are interested, many people are unduly reluctant to contact professional scientists. You think we're all too busy, but frankly, most of us are absolutely delighted and flattered if some young person expresses an interest in what we do, wants to learn about it. Undergrads working in my lab. I've had high school students working in my lab. Many of us want to make opportunities to help the next generation of scientists have the joy of discovery that we've had.
Some great advice, and glad to hear that you're trying to let anyone have an opportunity. So
Yep.
Contact Tom. That's how you get into salmon. The clarification for that earlier question was, what policies should we support? Should we support the hatchery? Should we support wild?
Well, When
Can you
there is a
say?
scarcity of salmon, kind of the two quickest things to do are to restrict fishing and to produce fish in hatcheries, right? That's kind of the quick things to do. Habitat restoration, we know, is important in the long run. Removal or modification of dams, all of those things are good, and I believe in them, but they take time. And so the crisis thing is to wrench back on fishing. And the fishermen always scream bloody murder because they say, hey, we didn't create this problem. It was habitat degradation. We're always taking the hit when other people are doing the damage. And that's not without some truth. And then in order to spare the pain, it's easier politically to produce more fish in hatcheries so the fishermen don't have to take a cut. But that's what leads us down this road. They say about the road to hell paved with good intentions. You could read things 100 years ago, more than 100 years ago. The salmon populations are going extinct. The fisheries are rampant. Nothing but hatcheries will save us. It's literally things that are ripped from the headlines 100 years ago. And I think it's become fairly well established in the scientific literature that an overzealous reliance on hatcheries has worked to the detriment of salmon. It's a complicated subject worth another whole hour or more, but we need to have them as part of our set of solutions. But I think our reliance on them has been too great. And I think we need to dial it back. And in many cases, the wild salmon would do better if we had less influence because the hatchery fish interbreed with them and there are some deleterious effects. Although I'm well aware that too is not a simple thing. We've come to rely heavily on hatcheries, and so dialing back on them would be painful and is running counter to the idea that if we want to have happy fishermen and happy fat killer whales, we got to make more fish in hatcheries. And it's just not that simple.
Well, yeah. Kind of depressing sounding,
No,
but yeah,
well,
that's the way it works.
I don't mean to be depressing. I don't mean to be depressing. There are salmon around, and if we value them, we have to learn to live with them. And that includes giving them some space, giving them some quality habitat, managing our interactions with them and moderating them. They're actually very resilient. They're not a canary in the mine shaft. They're very, very resilient, but we gotta keep our heel off their neck.
They've been in existence for so long.
Yep.
They've got the skills to survive.
They do.
Leading into the next question, what do you think is the biggest threat to salmon currently? Too many toxins, loss of habitat, increased water temperature, too much predation?
Well, it sort of varies who and where. Certainly in some urban streams, toxins, and they've been identified by some very astute chemists as being associated with the degradation of tires can cause acute mortality in adult cohos and actually in juvenile coho salmon. But we have many streams where tire runoff is not a factor and we're still short of salmon. So while those toxins in streams and in estuaries like Commencement Bay and Elliott Bay are a problem, we have many areas that are clearly not polluted that are also in trouble. So while I don't mean to minimize the importance of those, there are certainly broader forces at work. I mean, the climate-driven changes are very powerful, and this includes not just temperature, but the proportion of our precipitation that falls as rain or snow. As of course all you folks know, it doesn't always rain in Seattle. It always rains in the winter. We have very, very warm, dry summers, and our water supply, both for irrigation, for crops, for domestic use, for industrial use, and for fish, relies on melting snow. And it doesn't get nearly as cold around here as it does on places on the East Coast. So a very small change in our winter temperature, half a degree or so, strongly affects how much of that precipitation either falls as rain or melts during the winter rather than being stored as snow and melting the following spring. So one of the big effects of warming is not on the temperature per se, but the distribution of water. And this is something that is just very concerning in the scientific community, particularly for the species that either enter rivers early and are spending the warm parts of the summer, like Chinook in the upper Columbia, or juveniles that rely on space. And so the combination of temperature and flow changes from climate is really important. And there's no getting around that. We're also seeing really powerful changes in the survival of salmon in the ocean. And we're barely starting to understand those. And of course, we have no control over them. You know, we don't have a handle on that dial. And those, of course, are ones that we can forecast and we can help ride those out, but we're not going to be able to control those. And, the salmon have had lots of ups and downs, and it's not my nature to look at glasses as being, half, almost empty. I like to see what's in them. Like, the beer glass is always half full, but there are processes in the ocean. I mean, remember, in terms of the lineup, the ocean bass last. So things we do in freshwater to enhance the populations may be undone by the ocean. One of the most alarming is the increase in the mortality of adult salmon after they have escaped all the natural predators and fisheries in the ocean because the rivers are getting warm. We see this most dramatically in Lake Washington sockeye. There's a horrible phenomenon referred to as pre-spawning mortality. And this is not just contaminants. This is some combination of pathogens that afflict them more when the water is warm, or the lower oxygen in warm water, or the stress. So in a number of places, including actually some up in Alaska, when they have years that are warm enough, we're seeing substantial losses of salmon that would have otherwise survived all the natural mortality in the Fraser River, in the Columbia River. And this is, almost certainly temperature related. And those are really alarming because in some cases, those losses are very severe and might thwart the efforts at habitat restoration and things like that. Again, I'm involved in work studying these things. They're extremely pressing and timely. Those are worrisome. So ocean conditions and some of these climate level processes are big effects, although you do have some populations that are doing darn well. And so it is not all doom and gloom.
It's good to know. And the fact that everyone wants like a whole, like, what's the problem? What should we focus on? But it's individually, you have to look at each stream to see. So it makes it a lot more complicated.
And scientists typically say it's complicated, but in fact, in the case of salmon, it actually is. Unlike, people say, well, it's not rocket science. Well, actually, it's a lot more complicated than rocket science because physics and engineering are deterministic, right? In the case of salmon, you can do things exactly the same and come up with different outcomes. Ecological processes are not always deterministic and much more difficult to forecast because the nature of the relationships. And that's not just an excuse from someone who's not as smart as a physicist. I think there really are levels of complexity that are genuinely challenging.
For sure, biology. We do have a comment about if you would like to share those geography papers.
If you get the contact, I'll remind me, Clarissa, and I will send you. It's written by a guy named Dave Montgomery. He's a very, very sharp guy. And I think I've got a copy, an electronic copy, and I'm sure Dave would be very, very happy if the paper were distributed. So that's something that I'm very much at liberty to do.
Okay. And then I wish we could get to all these questions, but we have run out of time.
I'm delighted to have a lot of questions. That's always a good sign for me.
It means people are interested and engaged, which we love to see. If we didn't get to your question, I can email them to Tom and he can email me some responses that we can add back into the comment section. But
sure. And if people want to contact me, they can find me through the University of Washington, tquinn@uw.edu.
So, Tom, I want to thank you so much for sharing your all of your salmon knowledge with us tonight and the research that you've done. That was pretty eye-opening to see. Thank you everyone who joined in on our live Facebook stream and commented. The next one that we're having is going to be on January 6th. And that will again be from 6:30 to 7:30. And we will have Ellie Kinley. She is the president of the Sacred Sea nonprofit, an Indigenous-led nonprofit that specializes in the Lummi people, and telling us more about their relationships with orcas and salmon. So mark your calendars for that talk in January.
All right. Thank you very much, Clarissa. Good night, everybody.